Good morning, distinguished college. It's an honor to present our proposed NanoStem Flex module, a nanochemistry module that based on the Finnish monomatous operators approach, designed to foster sustainable STEM thinking among students. This work is a collaboration between myself, Dr. Richeal, and my co-researcher, Madam Almasiah, from the Institute of Teacher Education Malaysia, Tawau campus. Well, what is nanochemistry? Nanochemistry is a highly relevant to sustainability. It provides a scientific and practical solutions to pressing a global challenge, nanocatalysts for providing a clean energy and hydrogen productions, the nanomaterial for water purifications and air filtrations, and nanobiosensor for environmental monitoring. From an educational perspective, nanochemistry make a chemistry visible, tangible, and futuristic. It brings a textbook knowledge with real-world sustainable solutions, giving students a sense of purpose in learning. We go to our next slide. Why nanochemistry? Well, nanoscience is considered a frontier in a modern science, focusing a material at a 1 to 100 nanometer scale, where unique quantum and surface phenomena occur. By introducing a nanochemistry module, we provide a structured pathway to integrate a sustainability context into chemistry educations. Activities are rooted in the real nano applications, and the module is explicitly aligned with UNESCO Education for Sustainable Development Framework. Why module? This is the second question that we need to answer. Why module? Currently, one of the greatest challenges in chemistry education is that content is often abstract, fragmented, and heavily exam-oriented. So the proposed module offers a new strength, collaborative learning, which fosters empathy and system thinking, self-directed learning, which enhance autonomy and meta-connections, and the last one, digital learning, which support inquiry-driven exploration and global perspective. Why monomotor opactors? This is one of a Finnish strategy. Finland monomotor operators represent a flexible and multimodal pedagogy. What makes it unique is how it transforms chemistry from a content into a life experience. It supports reflective and ethical decisions making and has contributed to Finland's high performance in international PISA assessment. In designing this module, we focus on 4 learning dimensions: cognitive, a mastery of nanoscale concept and sustainability applications; affective, cultivating empathy, ethic, and responsible; behavioral, translating awareness into sustainable practice; and meta skill, future thinking, systematic problem solving, and digital inquiry. Okay, the NanoStem Flex model. Okay, as I mentioned, this is the 4. Okay, what is the illustrative activity of the NanoStem? Okay, from what we show you that the illustrative is the NanoStem Flex module integrate activities that are accessible and be impactful. Example like Nano Clean Water Challenge, creating a simple mini water using a sand and charcoal. Solar Nano Pen prototype, testing a natural pigments such as turmeric or spinach for solar absorptions. A nano food preservation test, coating a fruit with a cornstarch or allogel to reduce spoilage. Future nanocity simulations, they will sketch and model a nanocity for 2050 with a nano-inspired solution, and nano-ethic debates. In the term of communication, they have a role-playing ethical dilemmas in nanotechnology related to health and privacy. Okay, the research proportions. Our research is proportion and grounded in design and development research, where we have 3 phases. The first one is need analysis, involving curriculum review, teacher-student interview, and literature synthesis. The phase 2 will be design and development, constructing the module with monomatous effective strategies. And phase 3, the evaluation through the expert validation, pilot testing, and quasi-experimental design. The anticipated significance is in threefold: for educations, for policy, and for global disclosure. The methodology. This is the very important part of our research. The research methodology is adopt a quasi-experimental design with a non-equilibrium control group. The sample will involve 180 from 4 pure science students. Data will be collected to pre- and post-test on a sustainable STEM thinking and alongside with students' written reflections. The analysis will employ Markova, Ankova, and thematic interpretations to provide robust triangulation between quantitative and qualitative results. For closing, the NanoStem Flex model is more than just a chemistry resources. It's a transformative educational pathway connecting a nanoscience with sustainability, guided with Finnish innovations and aligned with global SDG goal. We believe this work have the potential to inspire a meaningful dialogue and collaboration in advancing sustainable STEM education across contexts. On behalf of my co-researcher and our institutions, I would like to extend my deepest gratitude to the conference organizer, fellow scholar, and esteemed colleague for this opportunity to share our work. Thank you so much.